Greetings, fellow mathematicians. We're going to take a look at a simple improper integral. This is the simpler of the two types, since we can see right from the integral that we have an infinity in our integral sign. So the first step is always you want to replace the infinity with a variable. I'll go with t, and then we'll take a limit as t goes to infinity. The setup here, rewriting it as a limit, looks like a limit as t goes to infinity. And we replace the infinity with the variable t in the integral. All right, so from here, this improper integral is set up correctly. We've defined it as a limit. And our first step is always to evaluate the integral. Once you're done with the integral, you can then take a limit of that expression as t goes to infinity. Now that integral is very simple. Let's go ahead and evaluate it. We have the integral from 0 to t, e to the negative 2x. And you might recall from when you covered substitution or a previous video where we introduced the 1 over a shortcut, we can easily integrate this. Our value for a is negative 2. So our antiderivative will give us a 1 over a factor, negative 1 over 2, e to the negative 2x. And we're going to evaluate that from x equals 0 to x equals t. That's the fundamental theorem of calculus at the end there. So from here, we just plug in. We're going to plug in x everywhere as t, and then subtract when we plug in x as 0. So negative 1/2 e to the negative 2t. Be careful with your signs. Your antiderivative has a negative. So let me use parentheses. All right, and this part was plugging in x equals t. That part is plugging in x equals 0. Notice we can simplify this a little bit. We know e to the 0 is 1, and the two negatives there cancel out. So we can rewrite this as negative 1 over 2 times e to the negative 2t, but plus 1/2. We can now immediately plug that in up here because that is the value of that integral. And that's what we're going to take the limit of negative 1/2 e to the negative 2t plus 1/2. So step 1 is done. We're done with the integral. Now we can evaluate the limit as t approaches infinity. So I always like to write this out. And what we're taking the limit of was the value of our integral, negative 1/2 e to the negative 2t plus 1/2. Now at this point, with the limits, there's a lot of tools that you want to keep in mind. Definitely the best one is L'Hopital's rule, but for this limit involved here, this term, e to the negative 2t, that does not give us an indeterminate form. We don't need to use L'Hopital's rule here. We can just rely on some basic facts of some basic graphs that you probably already know. So over to the side here, like I would at the beginning of class when we cover improper integrals in my course, I just kind of outlined the basic graphs that we're going to see, exponentials, negative or decreasing exponentials, natural logs, very common functions like you might have saw in your pre-calculus course. And the one we want to look at, we have e to the negative 2t. Even though the variable here is t, but here it's x, it's the same basic shape. Your graph of e to the negative 2t has this same shape. It just decays a little faster. Now, how do we use that graph here? Well, notice there's an asymptote. As you go very far to the right, the graph of e to the negative x is going to approach 0. So if we write that using limits, we can say the limit as x approaches infinity of e to the negative x, the y values or function values are approaching 0. So that's our limit. And we don't need anything fancy for that. That comes directly from the graph. Now, how do we use that here? Well, if we take the limit of each part, the 1/2, that has no t's in it, so that's going to stay constant as 1/2. But what we're going to plug in or recognize is e to the negative 2t in the limit as t goes to infinity, that's going to approach 0. So this part approaches 0. We're not plugging in that expression as 0. As t approaches infinity, e to the negative 2t gets smaller. And what we're left with of our limit, it approaches 0 plus 1/2. So we get that our improper integral approaches 1/2. Now to state this, what we can say, this integral from 0 to infinity of e to the negative 2x, since this limit exists, that tells you that your improper integral is convergent, first of all. And the more important part, the value of the integral, what we get, is the value of that limit. So our improper integral is convergent, and we find that it converges to 1/2. If you were to graph this function, the graph of e to the negative 2x, which looks very much like this, but it just decays faster, this 1/2, that can be interpreted as the area beneath that graph of e to the negative 2x over the entire positive x-axis. So we get a finite area, even though the integral is over an infinite region from 0 to infinity. So that does it. We have a convergent improper integral. It converges to 1/2. Hope you enjoyed the video, short and to the point. If you enjoy the content, support the channel, like and subscribe.